Welcome back to this plenary session in GRA 6036. We're doing project 13. Now we'll do exercise C, which is reproduce to plot in figure 1. So plot in figure 1 is, well, these two plots where we know that we fitted quadratic models to the good-looking dataset and to the not so good-looking datasets. So let's reproduce these. This is then C. So we should fit to fit the models like this on both datasets. So let's call that fit1 GL and fit1 not so good looking, and then we add GL. So now we just entered the good looking data frame. We can just replace. Well, then we do not need, of course, that indicator because now they all have the same value, so it will not work. So it would be like this: GL and GL, and then we do not so GL and not so GL, and the same thing here. So now it should be great. We fit these two models, and then we make our plots. So on the x-axis we want experience. On the y-axis, so now we start with a good-looking plot. We want log wage. We remove the frames from the plot, and well, and we could, of course, then let's have a look at the figure. Make an xlab, which is years of experience. So now we're making sure that we get this nice caption here. Then ylab, that's log wage, and the main, so the header, this one, is good looking. And we make the same thing for the not so good looking groups. Then we add not so, and not so, and not so. So then we can put this in the same figure. So then we do par mf row equals 1, 2. And we get these two plots right here. And now we are to add lines to these plots. So now we pay attention because we cannot use abline directly on this object because there is not only one slope. So now I make an auxiliary thing I call UU, or maybe I should call it something else. Well, let's call it Z. So that's a sequence from 0, we see 0 here, all the way up to 48, say. And then the step length, we'll make that small. It doesn't, I mean, it just has to be small enough, but don't make it so small that R crashes. And then we do lines, Z, and now we add the predicted values. So then we should get the coefficients from this object. So that's coef. Here we see the 3 coefficients. We can enter them like this, and we get the first one. So this plus number 2 times C plus number 3 times C squared. Let's make it red, and the line width is 2. Okay, so now we do the same thing for the second group. So then we only have to add not so, not so, and not so. And then we can reproduce this figure. So here we go. So make sure you understand this code, and also let's stress this because these are what is called the predicted values. So this is what we often call, we can write that here. So is, well, not really. I mean, okay, so this is in the, well, these are in a sense predicted values, but notice that when we compute the predicted values, we do it for actual observed values of the covariates. So the actual values we have for expert. Here I just made some values, so there's a sort of a difference. So here I'm predicting values also for those values where we do not have data on experience. But I mean, yeah. So in a sense, there are even more prediction going on than when we only insert the expert thing. So I think I'll quit this second video right here and continue in a third one.